Let's see. Let's look at that one first. Do I? Yeah, that's on there. I was looking for one. So we know that's 80 degrees, that's 60 degrees. If I write something wrong, please tell me. It's angle 1, angle 2, 40 degrees.
There's 3 down there.
Where?
Right there where 2 is.
Down here. 4, 105, angle 5. Now with problems like this one, again, I told you this first semester, where a lot of you have trouble is, what's the first angle you want to try to find? Angle 1. If you do that, you're going to be lost, all right? Just start finding angles. Any angle that you can find, write it in, and go from there. If I'm looking at this picture, I don't even look at the 1, 2, 3, 4, and 5. I just start finding angles until I've found every angle that I can possibly find in the picture. So if I did this, give me an angle that we can find. You just have to explain to me where it's at.
80, 60 angle. The vertical.
That one there?
Yeah.
Is that what you're talking about? How can we find that?
180 minus whatever 1680 is.
It's a triangle right there, right? So what's 60 plus 80?
140.
140, subtract that from 180.
40.
So we know that angle's 40, I'll write it in. Give me another angle.
Vertical angle across from 105.
Vertical angle across from 105, that's right here. What's it?
105.
105, because vertical angles have to be congruent.
Angles on the side between the 105.
These? That one?
No. That one and the vertical angle negative.
Those two?
Yep.
What do we know about these two angles?
80 plus 180.
They got to add up to that straight angle, which is 180. So what's this angle? 75. Everybody understand that?
Yeah. 70 and 70.
That one's 75.
Angle on the other side. Like the 40 on that side, and then whatever's in the middle would have to equal 180, which would be 140.
So that one?
Yeah.
That one right equals.
So that's 140.
Yeah.
So now the vertical angle of 140 is going to be 140.
That one down here, those are vertical angles, so that has to be 140. What else?
The 40 is vertical.
Okay, so that one's vertical to the 40 that we wrote in. So that has to get 40 has to go there.
And one at the bottom there would be.
These three angles, there's a triangle right there, so they're saying that add these two, 75 plus 40,
It should be
it's 115, subtract that from 180.
65.
Everybody agree with Terry? 65? What else?
That means that other angle there should be 65 on the triangle upwards all around.
This one?
Yeah.
How come?
Because it's a 40 and a 75.
Oh, it's the same angles in that triangle as in the other one, right? So add those two up, subtract from 180, what's that angle there?
65.
65.
Wow.
About this one.
15 now.
Does anybody remember what should be true about these two angles right here?
Add up to the outside angle.
They should add up to that exterior angle, that outside angle right there, do they? What other angles can we find? We found every angle in the picture, haven't we? And once you do that, now could you go back and answer the questions and find angle 1, 2, 3, 4, and 5?
Easy.
Yeah. If you start off trying to find angle 1 first, though, you're probably gonna get lost. Other ones that you want to see? Go ahead, Mackenzie. 22. I'm not going to draw the whole picture. Is that all right? Is that enough, maybe? Yeah. We need the other end, don't we? I'm not drawing the whole picture. Dalton, he'll be up here drawing the whole picture. There, that's as whole as I get. So we got this. First thing, again, I don't even want to look at angle one. If we're trying to find angle one, that's great, but first thing I would do on this is find angles that I know I can find. Like if this is a right angle, what's this one over here? Right angle, 90 degrees, so I'd write it in. Can I find this one?
Yeah.
What do you know about these two
You
angles?
gotta subtract 145 from 180.
180 minus 145, they've got to be supplementary to each other. 45, 35. Now what?
And then you can add 90 and 35.
Got a right triangle there. You could add these two up, 90 plus 35,
125.
and then subtract that from 180. Or, I heard somebody else say, since it's a right triangle, we know that these two angles have to add up to be how much? 90, right? They have to add up to be 90, so you could just take 90 minus 35. These two answers should be the same. What's it give you? 45? 55?
Yeah.
So that angle right there is 55 degrees. Is that the angle we're looking for? What do you think this angle right down here is? 55 degrees. If I make Dalton happy over there, what do you think that angle right there is? 55 degrees, so on, so on, so on. In construction, you see a lot of triangles in construction because they're rigid figures. We talked about that before break. They're rigid figures, and that means that they don't have much give to them. 24? 24. Remember, 24 is one of the problems that I said we were going to do several of as the year went along. It says, is it possible for a triangle to have angle measures in an extended ratio of 1 to 4 to 7? 1 to 4 to 7. If I just draw some random triangle here, doesn't matter what my triangle looks like, if I just draw that, they're telling us that the angles are 1 compared to 4 compared to 7. Does that mean this angle's 1, this angle's 4, and this angle's 7? What do we say you've got to do every time you see that? Put what? Put a variable with it. So now remember this, and they had a long break, so every time you see a ratio, this extended ratio, put a variable with each one. So instead of this angle just being 1, it's 1x. Instead of this angle being 4, it's 4x. This angle being 7, it's 7x. Can I set up an equation from all that? What would it be? 1x plus 4x plus 7x, those are the three angles of that triangle. They should equal 180. Ignore the extra tall 1 there. What's 1x plus 4x plus 7x give us?
12x.
12x, everybody agree with that?
Sir.
Equals 180. Have your calculators out. Divide both sides by 12. 15. So that means x is 15. Now we got to sort of go back and make sure that that's going to make sense. How much is this angle right here then?
15.
15 degrees. How could we find this angle? 60 degrees. 4 times 15. How about this angle?
75.
75 degrees. Everybody agree with that? What should those three angles add up to be? 180. Does 15 plus 75 plus 90 give you 180? Yeah.
7x is wrong. It's
Yeah, that is wrong. Dang.
5x.
7x is 105.
Yeah.
Now do those add up to give you 180? Tell me 75.
Killing it.
Trying to do it in your head. Got that calculator in your hand. Other questions? What are some key ideas you need to remember here? It's not just for this problem, for any of them on here. What do you know about the three angles of a triangle? Add up to 180.
Don't always do one. 1/3.
Do what?
Don't always do 1/3.
Right, don't always find whatever you can find. What do you know about angles like angle 1 and angle 2 right here?
They equal up to 1/8.
They add up to 180, they're supplementary angles. What do you know about angle 1 and angle 2 here? Vertical angles, they have to be congruent, so on, so on, so on. So you gotta remember all that stuff. What we learned first half of the year is not gonna go away. We're still gonna be using it all the time. 25. 25. A couple other things that you need to remember. Isosceles triangles and equilateral triangles. Talk a little bit more about that here in a minute. That's supposed to be a 20 there. What kind of triangle is this one? Isosceles. One of the rules that we had right before break, if these are the legs of an isosceles triangle, what do you know about the angles across from them? They're congruent. So if this one's 50, what's this one? 50. If this one's x, what's this one? X. If this one's 3x plus 20, what's this one? 3x plus 20, so let's write that in there. Now, can we set up an equation from all that? Tell me how. Tell me what's right.
3x plus 20.
Plus 3x plus 20.
And then plus 4x. Add 8.
Now what?
Add plus 20.
Combine like terms, collect like terms. 10x plus 40 equals, now what?
Minus 40, 80 side.
What they ask us to find is, I'm doing this real quick. Did they just ask us to find x? Now what?
Divide
What's x equal? 14. So they didn't ask us to find the angles. Going along those same lines, what kind of triangle is that triangle? Equilateral. What do you know about this angle right here then? 60 degrees. How about this angle?
60.
All right, what I want you to do, get out this start of your notes for today, get out these papers, start copying that down. Don't say what. If I have your binders, go there and grab them, I'm sorry. There's some up on the shelf. Also, as you're copying this down, I'm going to pass this bag around. All you need to do is take a number out of it and lay that number there on your desk. Don't lose it. All right? I'll explain it here in a little while. Just take it out, lay it on your desk. Don't lose it. nice to him and then he's mean to me.
I just said thank you.
I'm sorry, Mr. Russo.
That says must know behind there. Must know.
Hey, she probably doesn't do this on the test board for me.
Usually.
I wish I was you.
Again, just take a number. Dawson's gonna make sure that he's writing this down. He's gonna keep his binder this time back on track. Doesn't want me to just keep pointing him out every day.
New year.
3 sections in your binder, notes, postulates and theorems, tests and quizzes. Everybody have a number?
Yes, sir.
Anybody not get a number?
Yes, sir.
Izzy, help me remember that I left this lane right here.
Same number.
I'm going to pull this number out. Peggy's going on the left, right? That would be Peggy's number.
The secret.
What I did, usually, in the past, I haven't done this, but I just thought I'd go back over a lot of this, try to refresh your memory a little bit. Things that you have to know for the rest of the year. It's not like all the stuff that we've done up till now you can just forget about.
Is one from addition?
Why did you forget that? I don't think Dawson wants me to write down all the stuff that you actually have to know to be able to do this, right? Getting dressed in the morning, not coming in here in the nude, stuff like I shouldn't have to write all that on the board, should I? So, Dawson, if we have to write all that on the board for you, you'll have to come in after school and we'll write it all down. So, some things, symbols and names, this first slide, symbols and naming different things. Naming lines, rays, and segments. How many letters name a line, array, or a segment? 2. 2, always capital letters. Now with a line, you could write out, I didn't put it on here, but it could be one lowercase letter, and you could write, it's going to switch on me because I didn't have it on pen. Previous. Option, pen. Sometimes you can name a line, line T or line R if that letter's out at the end. So don't forget that also. Triangle, symbol goes in front, 3 letters to name a triangle. To name a point, no symbol for it, just point G or point A or whatever it happens to be. Angles, these are the ones that everybody's messing up the most on. First thing, with vertical angles. How many letters is it going to take, if I could draw an arrow, how many letters is it going to take to name that angle right there? 3. You cannot name that angle with 1 letter. All right? No matter what, there's no possible way to name that angle with 1 letter because you don't know which angle you're dealing with. So you have to name it with 3. You could name it with 1 number if they happen to give you numbers, but not 1 letter. So make sure you're naming angles. When we first went over angles, I even said something about trying to use that method all the time because then you can't mess up. Use that, and you start here, and remember that the center letter has to be the vertex, then you'll be safe all the time. But this angle, and there's one way I didn't put up here, this angle could be named angle EDK. It could be named just angle D because there's only 1 angle with that vertex, or it could be named angle 3. What's the other way that angle could be named that I didn't put up here? K what? KDE. KDE. Going backwards. All right? So that, make sure you know all that stuff. Formulas. 4 formulas. Again, we get to the EOC test here in a couple months, they don't give you these formulas.
What's that?
End of year test, state test. So you gotta know them. Just like all that, which I erased it. All the rotations and reflections and all that stuff, they don't tell you none of that either. You gotta know it. I'll start walking on this side. Make sure you copy them down carefully. Probably you might want to add the quadratic formula to that list. I didn't put it on there, probably because I wasn't smart enough to figure out how to put it on the computer. Tried to get a hold of Molly over break, but she wouldn't answer my calls to come help me. Goes back to another one of those. Nobody likes me, like Dalton said earlier, right?
I like you. You're really nice.
Come on, guys.
Shouldn't
Kind
you
of
say
pushing
nobody
things
likes
a little bit. It's kind of strict.
You know what I mean? I'm sure you do.
Midpoint formula, you're just finding the midpoint of a segment. We'll talk more about midpoint here in a couple minutes. You just add the x's, divide by 2, that's one answer. Add the y's, divide by 2, that's the other answer. Both these first two here, actually all of them more than likely, you're going to be on a coordinate system. You're going to be on a graph. So you're going to have an x-axis and a y-axis. Distance formula, you find the distance between 2 points. You might remember that distance, if we're looking at distance from something to something, it's always got to be the, what's that symbol mean? The upside down T? Perpendicular. It's always got to be something going perpendicular to it. So you can find the distance. Slope formula, might want to write in there, instead of subtracting the y's on top and subtracting the x's on bottom, what's the better way that you guys probably remember? Rise over run. How much up or down you go, how much left or right you go. Slope-intercept form, everybody always gets these two confused. That's why I put this one on there. This is actually the slope-intercept formula of a line. This is the formula of a line. This is just to find the slope of a line. Two different things. So next time somebody asks you for the slope formula, don't say y equals mx plus b. That's slope-intercept form of a line, of a linear equation. Just walking back and forth. I figure you're getting lonely sitting over there all by yourself, son.
No, I like it.
Remember all that, Jenna? Didn't forget everything over your little break. Some key terms. Congruent.
Yep.
What's congruent mean?
Same like length
So
or
we
whatever,
break that
same
one too.
measurement.
Yeah, it wouldn't be a bad idea to put quadratic formula on there also.
Same measurement as something else.
Same measure, things that have the same measure. Congruent.
That's true.
Things that have the same measure. What are supplementary angles?
Add up to 180.
Be careful now. Two angles that add up to 180. Get that too. What are complementary angles?
2 angles add up to 90.
Two angles add up to 90. Vertical angles, I drew you a little picture there so you could point out which ones are vertical angles. What do you know about vertical angles? Right, the theorem that we use the most.
Angles are congruent.
Vertical angles are congruent. Vertical angles are always congruent.
I don't want it to shock me. That doesn't mean doing it. It didn't shock me.
Just blackberries. If your hair get all black from being in the sun, you die.
It was, and then I got hives.
Now, are there a lot of other things that I haven't put up here that you should probably know? Yeah, I'm just going back over some very, very basic key ideas. If you don't know these, I'm going to cry.
So you should have these memorized.
Yeah, senior year I should.
Thank you, Elijah. See, I'm trying to be nice. I came back trying to be all nice, and he's being sort of a jerk, isn't he?
I got you.
I was tired.
Haven't said not one bad thing yet, and he's over here just.
I'm bashing, I'm sorry. It's the first day back. I apologize for sure,
Notice I don't care if you hurt my feelings. What hurts my feelings more is.
Let me hear my senior year. That's.
See, I'm trying to.
Are these key terms too?
Yep. Some people's grades, that's what hurts my feelings. Again, make sure, as they're talking about grades, make sure that you look over, go onto your Moodle at some point, look over, make sure I didn't mess anything up, because when grades get downloaded, now I can go back and change it, but once they're on there for the 9 weeks, it's not something that's easy for me to go back and change. Not something I enjoy doing.
We don't have anything there.
Midpoint. Midpoint splits a segment into two, is a point that splits a segment into two congruent segments. If you need to draw yourself a little picture there, then draw it. Midpoint. Segment bisector. Segment bisector, a midpoint is a segment bisector. But does a segment bisector always have to be a midpoint? No. So midpoint, horrible drawing, midpoint might look something like that. That's your midpoint right there. Segment bisector could be a point. So it could be just that point, or it could be some line that runs through. Sorry, flipped on me. Could be some line that runs through there. But it still splits a segment into two congruent segments. Angle bisector, anything that splits an angle into two congruent angles. Start of the year, I might have been, instead of saying anything, I might have said it has to be a ray. Probably should be mathematically, it's a ray that splits an angle, but we don't even care. You can remember, splits that angle into two congruent angles, two equal angles, that's good enough for me. Perpendicular lines, that upside down T, the thing to remember about perpendicular lines, anytime you have perpendicular lines, they come together and they form what?
Right angle.
Right angles. Very good. Parallel lines, what's the key word in that parallel lines definition there that I gave you? Coplanar. What's coplanar mean? Same plane. How come we need to know that coplanar? Because the definition that you had in the past were two lines never intersect. These two lines never intersect. Are they parallel? No. All right. So don't forget that, hey, you've learned a little more this year than what you've learned in the past. They have to be on the same plane. This metal strip right there going across this way, and this line on the floor right here going right by Jenna's foot, they're never going to intersect, but they're not parallel to each other. Again, if you're not happy with your grade, binder, just little stuff. Do your homework each day. I know I'm a real jerk about homework, right, Jason? And when I come around and check it, Jason will have problem number 6 wrong, and I say, I ain't giving you credit for that. And I just won't give him any credit whatsoever. Isn't that the way I check them?
But at least have like over half done.
All right, if you got most of it done, it looks like, and you've tried, get credit for it. I love all of you to death, but the only time I want to see you after this year is as you're walking down the hallway.
I'm there.
Parallel lines, a symbol for parallel lines, just that. Symbol, if we're on a graph, looks like that. And I just wrote these down real quick, different pairs of special angles that we have when we have parallel lines. Alternate interior angles, alternate exterior angles, corresponding angles, and consecutive interior angles. Consecutive interior angles. Yeah, sort of. I've abbreviated all this because I was tired of typing when I got this far. So if you're not sure, write it out. Alternate interior angles. Do I care if you spell it wrong? Not really, it's your notes. As long as you know what you mean. Alternate interior angles, alternate exterior angles, corresponding angles, consecutive interior angles. If the lines are parallel, what do we know about alternate interior angles? They're congruent. What letter could you put there beside those to help you remember? A C. Z or an N, right? So by alternate interior, you might want to put the Z there. Bad thing with putting the Z on the exam, I think it was on the exam. Had somebody, when I had said to explain why they're the same, had somebody put down, they form a Z. That's true, but that's not really a mathematical rule that we can use. All right?
We're just the bottom one.
Consecutive interior. Consecutive interior angles. Name me a pair of alternate interior angles in the picture over there.
2
Say it again.
2 sides.
2 and 7, 4 and 5. All right, so 2 and 7 are alternate interior. They have to be congruent to each other if those lines are parallel, which those arrows tell us. Name me a pair of alternate exterior angles.
1 and 8.
1 and 8. Name me a pair of corresponding angles. Remember, with corresponding angles, what do you do with the two lines? Smash them together. 1 and 5 would lay over top of each other. Name me a pair of consecutive interior. 1 and 2. Don't sound right. Consecutive interior. Which angles are interior angles? There's 4 interior angles. Which ones are
4, 5,
they?
7.
2, 5, 4, and 7.
So it would be 2, 7.
Which ones are consecutive interior angles? 2 and 4. No.
Consecutive.
2 and 5. The roommates. Remember, if that helps you, the roommate ones. The ones that are, there's nothing in between it. I know I spelled roommates wrong, but what are you laughing about? See, you keep saying stuff, and it makes me want to.
I didn't say I was laughing at you right now.
I know, but you say something like, I asked you what you're laughing about, and you said life. Then I got 1,000 smart aleck comments I could throw back at you. You're just like, this is your, this is your head, and you're like putting a bullseye right there on it, saying, here, Mr. Eversole, hit me right here.
Shoot your shot.
I mean, I got a big head, it's not hard to miss.
Inductive and deductive reasoning. Inductive reasoning deals with patterns. Deductive reasoning deals with facts and rules. Not putting a whole lot up here about chapter 2. Yeah, you just put it right. All this just sort of all goes together. Nothing special. Inductive reasoning, patterns. Looking at something. You've seen the same thing for day after day after day. And you think tomorrow you're going to see the same thing. That's inductive reasoning. Deductive reasonings, like when we're doing the 2-column proofs and you're saying, okay, I know this is true because this. I know this is true because of this. I know this is true, so you're using facts. Okay, nothing hard about a binder. Keep your binder. Keep the notes right there in where they belong. Should be easy. Just write this stuff down each day. You know, Kelsey's got someplace better to be for this 80 minutes, but since she has to be in here, might as well write it down, right? One day at a time. Keep it up one day at a time. Should be an easy grade. Scale factor. Scale factor is always image over pre-image, length from the image, compared to the length or area or whatever it is for the pre-image. Image, new or old? New. So if you wanted to put new over old, image over pre-image, whichever way you like it, that's fine. Triangles. Different kinds of triangles, very important because we're going to deal a lot with triangles this upcoming chapter. Be able to name triangles according to their sides, be able to name triangles according to their angles. Why do you think I put those little asterisks out there?
There's a lot of hours.
Important.
Those are important. Alright, those are important. Isosceles, equilateral, equiangular. Those are important triangles. Right triangles, maybe I should have put one out, put the asterisk out there beside right also, because they're important.
So basically just one with the stars you can write down.
Okay. Your notes, I'd like you to, I took the time to type them on there. Probably took me 3 times longer to type them than it's going to take you to write them. Like I said a minute ago, Kelsey, you got someplace else to be right now? You can't be anywhere else, right? You have to be in here, so might as well write it down. at the end of the day, Dawson, I can say, Dawson, what's your grade on your binder for the third 9 weeks? And you're gonna tell me what? 100%, because you got everything down for today. And that's all that we have so far. Then if I ask you, Dawson, how much better is that binder than your second 9 weeks binder?
Like 100 times better.
Scalene triangle, no sides congruent. Isosceles, at least 2 sides congruent. Got to know a lot of stuff about isosceles. One of the other slides will deal with it here in a minute. Equilateral triangle, all 3 sides are congruent. What do you know about an equilateral triangle and an equiangular triangle? Same thing. If it's one of them, then it's the other one also. So those two sort of go together. An acute triangle has 3 acute angles. Obtuse triangle has 1 obtuse angle. Right triangle has 1 right angle. One other thing I might say about an equilateral triangle, what do you know about every angle? All angles are 60 degrees. All angles are 60 degrees. Same thing for equiangular. It doesn't work either. Plus they can add if you put duct tape on the wall. Because it leaves a bad film on the wall. Usually that gum stuff has worked pretty well here the last few years, but it's not working this year.
Probably cool.
You ready?
Oh, that's fun. Alright, thanks.
Proving 2 triangles are congruent. 4 ways to prove them congruent. You don't have to skip space like I did here. Just be able to prove 2 triangles are congruent. Should know those 4 ways. We just went over that not too long ago. Is that Dawson?
That's pretty Matt Dawson. No.
Doing the work on it. Or did you quit on me? Did you quit on me again? Okay. Everybody got that much?
Yes, sir.
Next one, some important theorems and postulates. I'm not sure why postulates is lowercase.
That's about to fall out. Realize that's about to fall out of his pocket.
Wish I had that size.
Right quick. We can hurry up and get through this.
They call that Walmart thing.
My stuff.
Huh?
My stuff.
Key rules to remember. First one, vertical angles are congruent. Second one, 3 angles of a triangle must add up to 180 degrees. Third one, anything equals itself. What property is that? Anything equals itself?
Reflexive.
Reflexive property, good. Next one, 2 points make a line. Next one, 3 non-collinear points. I'm not sure why I put space in non-collinear there. 3 non-collinear points make a plane. Just some key rules that we went over first half of the year that you have to remember. Ethan, what's the number you drew?
17.
Have your numbers laying on the corner of your desk so I can look at them here in a second when we walk around. Everybody got this much?
Yes.
Pretty close, Elijah?
Yeah.
Four more rules. Sorry. Last thing, write that down. As you're writing that down, remember this is the isosceles triangle theorems. If two sides are congruent in a triangle, then the two angles opposite them have to be congruent. The other one, if two angles in a triangle are congruent, then the sides opposite those have to be congruent. What we will do, the worksheet will be your homework. The worksheet will be your homework, the one that you grabbed from up there. What you're going to do, one at a time, you're going to come to this paper and you're going to write down the example I'm going to put here. You're going to put B3. Why B3? That's your class. So you're going to write B3, then you're going to write your number. So B326, whatever it happens to be. All right, and that's all you're going to put right underneath student in this first column. And put no, you don't put your name on there. And put your number back in the little bag there. Put your number back in the bag. Put your thing on there. This might help in case anybody gets mixed up over there.
I know my granny names.
Put it in the bag. Two plus. B3 than that number. B3 than that number. Put your numbers in the bag for me, please.
I don't think I will. So I mean, a quarter will I guess. 15. Oh my gosh.
Let me get out of here before everybody starts.
It's right down B317. 317.
Jamal, you're just gonna be the right. I'm done. I think we're gonna play Dolly when we get back. Like if we after lunch. Ginger, can I borrow that big line?
Brown. Walk to it.
Your bike, what?
My number.
Every day.
I mean, our class is sweet. Your class is not.
We have like 50 people now.
Maybe it might be sweet.
I might drop somebody off.